Hello, chemistry students. Mr. Skony here. I want to walk you through some of the ionic bond basics. Welcome to a new unit. We're going to put to work a lot of what we learned in the last unit, simply about atoms and their electrons. We're going to put that to use and see how they actually react with each other, which is the fun part of chemistry. Let's start by simply looking at our friend, the periodic table. Okay. We talked about these Roman numerals and charges in the last unit. And what we discussed was that Roman numeral is the number of valence electrons. And this number here, you may or may not have heard, this is the charge when it becomes stable. Now, this is the area that we need to look at. What does that mean? How does it react? What does it do? Why do I care about it? Well, let's just simple background knowledge. Opposites attract. Okay, positives, negatives, magnets, whatever you want to say, opposites attract. We have some of these on the periodic table are positives. Okay, now, Mr. Skony, hold on. This one is a plus and minus. What am I supposed to do with that? Just hold off. We'll talk about that more in depth. I can tell you that this guy right here is really, really important in the world of chemistry and science. He has his own field of study. He's that important, but we'll get to that down the road. Main categories. You have the positives, you have the negatives, and we do have neutrals. Okay, if you remember, these are the noble gases. Okay, I'll put a little note here. Noble gases. Those are inert. They do not react, so we don't have to worry about them. Okay, inert. So they don't react, and the reason they do not react is because they have a full outer shell. They have fulfilled the octet rule. I'll show you what I'm talking about, but their outer shells are complete. They don't need to trade electrons at all. What we do have to worry about are these positives and negatives. Okay, so to do that, we'll start by looking at the ionic basic notes. You can follow along with these. You can put your own notes on them. Okay, I have to honestly tell you, when I first took chemistry, this example to this day stands out in my head as one of the reasons that I became so intrigued with chemistry. And it's the idea that we take sodium, which is the metal that we took and we put in water and it caught on fire and it turned purple. If you take sodium, so a metal that explodes in water, and you mix it with chlorine, which is a deadly gas, it'll kill you, and it's yellow. Okay, if you chemically combine those, now that's the key. Okay, I can't just put them into a room and have an explosive metal and that deadly gas. That I wouldn't be working for too much longer. I'd be fired after that one. But if I take those two elements, I chemically combine them, what I produce is table salt. That's it. I go from an explosive metal and a deadly gas to simple table salt. Okay, to me, that blew my mind. All right, that's a crazy idea to me, but that's the way chemistry works. You have two or more elements, they chemically react, and they form something completely new with new characteristics. And that's what we're going to look at of how this actually happens. Okay, so you can look through these notes. What I want to focus on here is the electron exchange. So an ionic bond is actually a process that takes place. And we'll use sodium and chlorine, and we'll go through it. So I want to start, let's identify these, okay, on the periodic table. So we have sodium over here, and it has one valence electron. And we have chlorine way over here. I'm sorry, I circled the wrong thing. Oh my gosh, don't tell anybody. It has one valence electron, and this one over here has 7 valence electrons. Okay, let's look at these. Let's put them together. Let's look at sodium. Na. And, oh. Okay, so we're going to do its orbitals, our Bohr orbitals here. And if I look back, I can split screen it if I need to. Sodium is number 11 on the periodic table. So that means it has 11 protons. I'll close this off. 11 protons in its nucleus, and it's going to have 11 electrons outside of its nucleus. So let's do that. First one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Forgot to draw another orbital. Second mistake of the lecture, if you're counting at home. So currently I'm at 10, 8, 10. There's my 11th electron. All right, let's go over to chlorine. And our friend chlorine, way over on the other side of the periodic table. Okay, he has, or she, not sure, has 17 protons and electrons in this state. Okay, so let's go ahead and do that. So, nucleus, second row. All right, so let's get the electrons on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, so a lot of work. Here we are. Now, the goal of the octet rule is it's going to want 8, everyone wants 8 valence electrons, 8 outer electrons, 8 in the last shell. So sodium has to contend with this one, and chlorine has all 7 of these. Okay, now these work together really, really well, because all that happens, both of these have 2 options. Sodium can gain 7 electrons, or it can dump off 1 electron. Chlorine, on the other hand, can lose 7 electrons, or simply gain 1 electron. Oh my gosh, it's a match made in heaven. Look at this. I'm going to dump off this shell, and I'm going to take this electron, and I'm going to pull this electron and put it over in chlorine. Holy moly. I now have 8 on both sodium and chlorine. However, sodium went ahead and lost an electron. So sodium lost a negative, so it becomes positive. And over here, chlorine gained an electron, so it has 1 more electron than it used to have, and this becomes a negative. And we know, or we should know, that opposites attract, positive to negative. So I just basically created 2 magnets, okay, or 2 opposite poles for the magnets, or however you want to look at it. And now they're going to be attracted to each other. So let's review. I had 2 elements. They were neutral. They do not like to be neutral because their only thing they like to do is gain or lose electrons to become stable. Once they do that and they become stable, well, now they have a charge. Okay, so they go ahead, they have a charge, and now we're able to form an ionic compound. Okay, ionic compounds, let's go back to our periodic table, are made up of, let me clear this off for you. Okay, ionic compounds are made up of 2 things, and you can state this a couple different ways. So again, we have to identify and remember, I have my metals over here. I'm going to kind of squeeze over the metalloids there. Mind me. And I have the non-metals over here. Okay. So when I talk about an ionic compound, I'm going to clear off my amazing graphic. You can say it a couple ways. It's going to be made between a metal and a nonmetal, or a positive with a negative, or a cation with an anion. Okay, these are two new words to you. And I put these all in the same kind of column, I guess. So a metal is going to become positive. So if I look at all my metals, right? Positive, positive, positive. Mr. Skony, what about these right here? Well, these are the transition metals, and they actually transition between different charges. So we're not really going to worry about those right now. We will worry about them when we get to naming and formulas and everything, but you do have to understand that these are all positive, just generally speaking. Okay? And then over on the other side, you do have your negatives here. Okay, so metals become positive, cations, nonmetals become negative, anions. Now, that is not very fun. What is fun is how you're going to remember this. Nonmetals or anions, fine. Like antagonists, like the negative person. Metals, cations. Here's how you're going to remember it. You're going to put your hand up like your little kitty cat, and you're going to say cations are positive. Okay, so cations are positive. Okay, that's right. I just did that. Or if you're super boring and you don't want to have any fun, you could look at this T as a little plus sign. And remember that cations are positive. Okay. So if we're going to review the basics, we have ionic compounds are taking two or more elements. They are going to chemically combine them through a process where you gain or lose electrons. You become, you go from a unstable neutral charge to a stable charge, and then once you have two atoms with charges, or two ions, then then they can chemically combine and form an ionic bond. So here is your general definition all the way down at the bottom. Ionic bonds form when a positive and negative ion attract to each other because they're opposite charges. Okay, and then you can remember this is that all ionic compounds are neutral. Okay. Now we will get into more intricate compounds where you don't, or where you have more than two ions in play. But right now, what you have to understand is that you have a cation, an anion, positive, negative. They have charges. Those charges attract each other, and then those charges neutralize each other. Okay. So every ionic compound is neutral. All right. So we'll go over some of that stuff in the near future. Okay. Thank you very much for listening. Go Pirates.